Voila. Magic. Okay. So here it says determine the non-permissible values. Now, what is the only thing we're not allowed to divide by? Does anyone remember? 0. We're not allowed to divide by 0. If you have phones out, make sure they're away. So we've never really had problems before. In 20-1 you did, but before that we didn't, because you have 4, 4 would be over 1, or you had a half, or you had a third, anything like that, or you'd even have x over 3. None of those are issues, because what's not in your denominator?
There's holes in here.
No, it's you. I'll take it, because it's often really hot in here. No.
I would say it's
Oh boy. Okay, so, Mary. No. So, these fractions are not problems because they don't have 0 in the denominator, correct? Because we're not allowed to divide by 0. Even that last one is fine because the x is in the numerator. We agree? Can I go 0 divided by 3? Type it in your calculator. Go 0 divided by 3. Nope. 0 divided by 3 is 0. So can my numerator be 0? Can my numerator be 0? Can the top be 0? We just typed in 0 over 3 equals 0. Was that an error? No. So can the numerator be 0? Yes.
I don't think it
Took you a long time to
I thought it was in the booklet when I started looking at this.
All right.
Thank you.
So, our problem happens. Paying attention or I will lose you. This is not an easy unit. If you have your phones out, you'll be lost. And then if you come ask me questions, I'm just going to look at you like this. Cool. We've all agreed. Great. So no more phones out because I saw 4 just like 3 seconds ago. All right. We have x plus 1 in the numerator. We agree? Is there any problem with that? No, because our numerator can equal 0. That's not our issue. Our issue is when we end up with variables, so letters, in our denominator. Does this one have letters in our denominator? Yes. So if they are only asking you for non-permissible values, NPVs, people put NDPs. It's not like a most valuable player. It's NPVs, just so you know, because it gets said wrong all the time. So non-permissible values, NPVs, are also interchangeable with the word restrictions. So the moment you have a variable in your denominator, you have to say what that variable can't be, because if it was that, your denominator would be 0, and we have problems. We're not allowed to divide by 0. Okay? That's why we stated NPVs if you were in 20-1 last year. Also in 20-2, because we guys discussed this. So let's look at this denominator. So we have 5x, that is not a 5. I just drew a line with it. 5x squared minus 5x. No, why? And it can't equal what? What can't my denominator equal? 0. If this whole thing works out to 0, I have problems. We agree? Therein lies the issue. If that denominator somehow turns itself into a 0, we have problems. We agree? Can the top be 0 though? Can that x plus 1 be a 0? Yes, because the top can be a 0, because 0 divided by something is 0. Okay? So we don't have to do it with the top. Now the bottom seems a little bit confusing with 5x squared minus 5x, right? Can we do something that we could take out of that that might make it easier for us, like a GCF for a difference of squares like we practiced on Friday? What could we take out?
5x.
A 5x. So we take out a 5 and an x, and then we write what's left over. When you take out a GCF, what operation are we doing? Yes. Nope. If you take a 5x out, when you're taking out greatest common factors, what operation are you doing? If I went to put this back in, what operation am I doing? Multiplication. So if I'm taking it out, what am I doing? Division. So what's 5 divided by 5?
1.
X squared, take out an x.
X.
X minus 5 divided by 5?
1.
X divided by x?
Nothing.
Just 1.
Or 1.
Yeah. So remember, when you GCF out of 2 terms, you should still have 2 terms left in the bracket. Do you see that? So I had two terms to begin with, and when I took greatest common factor out, I still have two terms. And you will always double check your GCF by distributing back in. Okay, if I distribute back in my GCF, would I get what I had? That's what I can always double check. So if I go 5x times x, I get 5x squared. 5x times -1, I get -5x. So did I get back what I had? Yeah. All right. Now that 5 and that x, are they attached by plus or minus signs? No, they're multiplication signs. I still see foams out. So the 5 and the x are multiplied, so I can put them in their own bracket. So do you see that? Now anything in its own brackets, if it turned out to be 0, would make the whole denominator 0. For example, I have 5 I don't know why, and then x minus 1. If this turns to a 0, what's 5x times 0? 0. So that's a problem, correct? If that became a 0. Is this a problem if this becomes a 0? 5 times 0 times x minus 1 is still 0, correct? So technically, we need to find out all the x's that would make those brackets be 0. Can a 5 ever be 0? No. So is that 5 an issue? No. What about this x? What could I make this be that would make this bracket be a 0? 0. So I say x can't equal 0. Because if it did equal 0, this x would turn to a 0, and I get 5 times 0 times -1, which is 0. Then I take the next bracket and I say, okay, well, this bracket can't equal 0. So x minus 1 can't equal 0. How do I get x by itself?
Add 1.
Add, yep.
Yeah.
Add 1. So I get x can't equal what? Done. Those are my two non-permissible values. Now I can check them by plugging them back in and seeing if my denominator becomes 0. If it does, I'm right. If it doesn't, oops, and I gave you an NPV that doesn't actually exist. So let's look at this denominator. It's 5x squared minus 5x, and I'm going to check if x can't equal 0. That's my first one. So I'm going to plug 0 in and see. So I get 5 times 0 squared. Why does it keep drawing the 5s like that? And then 5 times 0. What's 0 squared? 0. 0 times 5 is? 0. Minus, what's 5 times 0?
0.
So what does it equal?
0.
So if I plugged in a 0 for my x's, I would get 0. So that truly is an NPV. It can't equal 0, or my denominator would be 0. We agree? Now I have to check the other one. I'm going to check x can't equal -1. Okay, so I go 5 times -1 squared minus 5 times -1. -1 squared is what?
-1 or 1.
1 times 5 is?
5.
5. And then -5, is it -5? Oh, we're supposed to be checking +1, Crystal. Hello. Look here, right here. Geez. 1 squared times 5 is 5. Minus 5 times 1 is -5, which equals 0. So I know that's also 1 of them. That's how I caught that -1 wasn't what I was supposed to be typing in, because when I looked at -1, I was getting 10, and 10 was fine. Right? So states and restrictions, or the non-permissible values, they're both the same. So we'd write them together. We'd say x can't equal 0 or 1, and then box it. That would be my answer. Because if I plug in 0 or 1, my denominator becomes 0, and I can't have it equal 0. Example 2, determine the non-permissible value or restrictions. Same thing, different words, same thing. For each of the following expressions. Do I care about the numerator? 3a minus 1. Can the numerator equal 0? 0 divided by something is 0, so that's fine. It's just the denominator. So I look at this. Is it attached by a plus or minus sign, the a and the 1? Yeah, so these are like sewn together, so I put them in brackets because they're stuck together. And the only way I can do anything to it is taking out a GCF. Can I take out a GCF by a and minus 1? Is there any GCS I can take out? No. So if there's nothing I can do, I just say, okay, well, I'll take that bracket, a minus 1, and I say it can't equal 0. Right? because my denominator can't equal 0. How do I get a by itself? Add 1. So I'm saying a can't equal 1. Well, let's check it. If I plug 1 back into my denominator, it should be 0 if this is true. Correct? So plug 1 back in. What do I get? 1 minus 1. It's a minus 1. And that equals 0. So I'm right. Because you're trying to find what the variable can't be, because if it was that, your denominator would be 0, which we can't divide by 0. Okay, let's look at B. Do I care about the 4 in the numerator? Do I care about the numerator at all if I ask you for non-permissible values? No. I care about the denominator. Is it attached by minus sign? Yes. So I put brackets around it. Now, can I go and say 2k squared minus k can't equal 0? Yeah. I move the k over and I divide by 2k. That's complicated, right? That's weird. So what should I actually be doing? What can I do to that? Take out a k. GCF out of k. So I get a k in front. 2k squared divided out of k is what? 2k. I'm hearing people whispering it. That's right. Negative k divided by k? Negative 1. Now before I move on, I check out my GCFing to see if I actually did good math or not. Right? See if I did something correct. So I can pretend to distribute it back in and see if I get what I had before. Correct? So k times 2k is 2k squared. K times negative 1 is negative k. Did I get back what I had? Yes. So then my GCF is good. Okay? Now, either of these, the k and the 2k minus 1 can't equal 0. Because if this equals 0, 0 times 2k minus 1 would cancel. If 2k minus 1 equals 0, k times 0 would cancel. Correct? So once I take out the GCF, my next step is to take each of these separately and say they can't equal 0. So k can't equal 0, and the bracket 2k minus 1 can't equal 0. K can't equal 0 is done already, because there's no solving left. What do I have to do with the next one? I have to get k by itself, so what am I going to have to do? Add 1. So I get 2k can't equal 1. Divide by 2. K can't equal a half. Can I check my npvs? Yeah. So go to your calculator and go 2, we're checking this, 2 times 0 squared minus 0, and then we're going to check the half. 2 times 1 half squared minus 1 half. Check them each up. See if you get 0. Check them in. Yeah. Yeah. Good luck. He's trying to get out. So type them in. Are they being typed in currently? So when we type 2 times 0 squared minus 0 into our calculator, we get 0, which is cool. When I go 2 times a half squared, that's 2 times a quarter, which is a half. A half minus a half is 0. So if you type them both in, they both end up being 0, correct? Well, so then that means you're good. So then you write your answer together. You say k can't equal 0 or a half. Sometimes they ask you to explain why they can't. Well, they can't because if k equals 0 or k equals a half, and I plug them into my rational expression, my denominator would be 0 and I can't divide by 0, right? That's the reason why you have non-permissible values. Okay, let's look at C. Is C attached by a plus sign? So I put in brackets. And that's all attached. So I say, okay, well, 2m plus 10 can't equal 0. Right? Can I do anything to it? Take out a 2. Then I'm left with m plus 5, because it's division. Even though that looks like a 6, because it's stupid and it's connecting my 5s. Now I pretend just to read it back in, see if I get it back. 2m plus 10. Yeah, I got it back, right? Then what do I do once I have my GCF out? I take each of my brackets and I set them not equal to 0. So 2 can't equal 0. That's just a true statement, correct? But it doesn't have any problems because there's no variables in it, right? Variables are the problems. So cool, that's a true statement, gets me no NPVs, right? 2 just can't equal 0. That's true. 2 will never equal 0, it will equal 2. Then I take the next one, m plus 5. Well, that one has a variable in it, so this will be more helpful. M plus 5 can't equal 0. And then I subtract my 5. M can't equal negative 5. And that's my only NPV, right? And if I plug it back in, I go 2 times negative 5 is negative 10 plus 10 is 0. So I know I'm right. Correct? Okay, let's look at D. D has x squared minus 49. Goes in brackets. Okay. So I say x squared minus 49 can't equal 0. Can you spot anything with x squared minus 49 from what we did on Friday? Yeah.
49 is the perfect square.
Yeah.
So
7. And 1x squared is a perfect square too, right? And they have a difference sign. So it's a difference of squares. The difference of squares, remember we take the square root of the first one, square root of x squared is x, square root of 49, Ava said is 7, which is true. And then I get two brackets, 2 factors. What's the sign difference? What do I put in them? One's positive, one's negative. Doesn't matter which one. No. I get an x in the front of each bracket and a 7 at the back. And then, am I done? No, I need to take each of those and set them not equal to 0 and solve, right? So I get x plus 7 can't equal 0, and x minus 7 can't equal 0. This one I'll subtract my 7. And I get x can't equal negative 7. So I'm going to add my 7. And I get x can't equal 7. And then the way they'll write them is they'll go x can't equal plus or minus 7. So write it as a positive negative 7. Okay? In either 20-2 or 20-1, you guys have taught this already. Okay, we're going to flip over. What does this one say? Your turn. A, C, and B for now, please. And then we're going to go over that review stuff for your test for tomorrow. So, we do brackets, and we say negative 2x minus 4 can't equal 0. What can I take out of there? 2? Okay, I'll take out a negative 2? Yeah. I'm going to show you no matter if you took out a 2 and I took out a negative 2, we're going to end up with the same NPV, unless you made an oopsie. So if I take negative 2 out of negative 2x, I'm left with x. Negative 4 divided by negative 2 is positive 2. Now that negative 2 is in its own bracket, and we take each bracket, set it not equal to 0. So negative 2 can't equal 0. Does that give me any NPVs? No, it's just a true statement. So I crossed it off. It doesn't give me any NPVs because there's no variable involved. It needs to be a variable. And then I have x plus 2 can't equal 0. Subtract 2. And x can't equal negative 2. Okay. With B, what can I do with B?
Difference of squares.
Difference of squares. So I have a squared minus 81, in its own bracket, can't equal 0. So I have a minus 9, a plus 9, because of the difference of squares. So I have a minus 9 can't equal 0. A plus 9 can't equal 0. Subtract or add the 9 over, so I get a can't equal 9, and a can't equal negative 9. So a can't equal plus or minus 9. C, what could I do? What could I take out? A p. And when I take a p out, I get 4p minus what? 1. So I have p can't equal 0, and 4p minus 1 can't equal 0. Don't forget the 1. And so 4p can't equal 1. P can't equal 4. Because you divide by 4. Now, I would hazard you not to skip this step, because people will tell me it's 4, not a quarter. They'll flip them in their heads. So p can't equal 0 and a quarter. Okay. Then I want you to flip to this booklet. Now, tomorrow, your test is on all of this, correct? It's an open book. Your closed book is next week on the 2, on set theory and terms and comp. It will be on Wednesday. We are moving on to rationals in the meantime, but it will be on the 2 of them. So we'll still practice those questions daily, but the test will be next Wednesday, closed book, so that you can get this one back, see what you did wrong before you write the other one. So it's an open book tomorrow. So here it says using the word aardvark. So the first thing I do is I go A, R, D, V, A, R, K. Why do I stack stuff like this? So you can see if anything repeats to make sure you have a denominator, right? So every single one of the questions I'm asking, A, B, C, D, will all have a denominator. What will the denominator be? 3 factorial and 2 factorial. So, no restrictions. 1, 2, 3, 4, 5, 6, 7, 8. It's just 8 factorial divided by 3 factorial, 2 factorial. If you haven't attempted them and you're just writing them down because you haven't tried them out, it is not helpful for you tomorrow. It would have been much more helpful if you actually attempted them. He's just rechecking them. He did it. There's some people who have a pristine sheet. Pristine. Okay. So you get 3360. Okay. Then the word begins and ends in a consonant. Does it say it begins and ends with the consonants? No, it says begins and ends in a consonant. So our denominator is going to have 3 factorial, 2 factorial, because it's going to for every question. The top is 8 letters. 1, 2, 3, 4, 5, 6, 7, 8. How many consonants are in aardvark? There's how many consonants in aardvark? There are 5. R, R, D, V, and K. All right. So it begins with 5 consonants. Great. Begins with 5 consonants. And I use 1 up, so how many are in the last one? 4. So that makes it begin and end in a consonant, correct? How many letters have I used up? 2. How many are left for the rest blanks? 6, 5, 4, 3. Why is it beginning up with the 5? I don't know. We should have got 1200. Now C says the vowels must be together. Does it say together at the front? No, it says together. So we're still going to have 3 factorial, 2 factorial. We still have 1, 2, 3, 4, 5, 6, 7, 8. How many vowels do we have, guys? 3. So we have 3, then 2, then 1. How many letters are left? 5, 4, 3, 2, 1. And then what do? Multiply by what? 6. Always one more than the hook together numbers. And why is that? Because those 3 vowels can move in front, here, between the 5, 4, 4, 3, 3, 2, 2, 1, and back. So that's 6 other cases. So it's going to be 360. Now, the vowels cannot be together. Do you suppose I'm going to give you a question where something can't be together tomorrow? Yeah, I absolutely am. If you're like, no, I hope she doesn't. She's me. I know what's on it. It's absolutely going to give you one where they're not together.
Oh.
So, that was a delayed one. So, vowels not together is not hard. What do? You take 2 of the answers I've already made you find. Vowels not together, all you do is you do the total, all of the absolute different words I can make from aardvark, and then I subtract off all the cases where the vowels are together. That's it. I already have them done. So the total is 3,360. That's the absolute max number of different words I can make from aardvark. And then 360 words have the vowels together, so I subtract that off. And what's left over are the words without the vowels together, which is 3,000. You did the hard work in A and C already. The next one says, a committee of 15 people with 11 boys and 4 girls wants to form a 5-person subcommittee to help plan for the end of the school year dance. Does that subcommittee have jobs? Do you have jobs on this subcommittee? Did it say there's jobs?
No.
No, it's a 5-person subcommittee. So if you're picked 1st, 2nd, 3rd, 4th, or 5th, does it make you any different?
No.
No. So is it a permutation or a combination? It's a C. It's a combination because order doesn't matter. So here it says how many committees can be formed if there's no restrictions. How many am I choosing? There's no restrictions. How many am I choosing? 5. From how many? 15. Done. And it keeps connecting my 5s, and I don't know why that is a 5. And you get 3,003. The next one says exactly 2 girls. What's that indirectly telling you? 2 girls and what?
2 boys. Large.
How many boys?
3 girls, 3 boys.
3 boys. Why is it 3 boys?
That's 5.
We're making a 5-person subcommittee. So you need to have 5 people. 5, right? Choose girls from girls, boys from boys, just like you would choose principals from principals, vice principals from vice principals, presidents from presidents, secretaries, secretaries, defense, forwards, right? That's whenever you choose from the exact same group it is, it's always a combination. So there are 4 girls, C2, times 11, C3. You can get your own answer. Don't leave them like that on the test. Figure them out. I'm just running out of time, so I want to be able to get through the whole thing. At most 2 boys. If it says at most or at least, what does that mean?
Up to 2 boys.
It means that there will be what?
1 or 2.
So I said if it says at most or at least, what does that mean?
0.
That means there's going to be cases, is what I'm looking for. There's going to be cases. That's what I'm looking at. At most and at least means there's going to be cases. We can't ask the 2 together because that would make no sense. Correct? But if I give you the word at most or I give you the word at least in the question, it means you're going to have cases. So this one says at most 2 boys. So at most 2 boys or at most $2 would be what? 2 or?
1.
Or?
0.
Yeah, so I could have 2 boys or 1 boy or no boy. Now I still need a 5-person subcommittee in each of those cases. So I need to supplement them, correct? So the 2 boys needs to be supplemented with and
3 girls.
3 girls And the 1 boy needs to be supplemented with 4 girls. And the 0 boys needs to be supplemented with 5 girls. What's my problem with the 5 girls case? There's only 4 girls. You can't actually do that one. You can't say 4 girls choose 5. You can't go 4C5. Okay? Then we would have 11C2 times 4C3, or means add 11C1 times 4C4. You can't do 4C5. It makes no sense. At least 3 girls means 3 girls, or at least 3 girls, at least $3.
3, 4, 5.
3, 4, 5. Catch is 3 girls or 4 girls is where I have to stop at. Why? There are only 4 girls. So 3 girls and 2 boys, or 4 girls and 1 boy. It's the exact same question as the previous one. It's going to be 4C3 times 11C2 plus 4C4 times 11C1. Actually the same question. Now, what if the subcommittee, all of them in that subcommittee have different jobs? What would it change it to? It'd be a P. And what would I do? How many would I have to choose from? How many would I have to choose from? 15 P5. I don't know why it's connected. It's driving me nuts. 15 P5. Because you'd have all 15 and they have jobs, so it's a P, right? Okay, here we have at a baseball tournament there are 15 teams. How many different games will be played if everyone plays each other once? It's a baseball tournament. Yeah. How many people play at a time in a baseball game? 2. So I'm going to say if they're playing each other once, I go 15. There's 15 teams, and I choose how many to play? 2. That's it. 15C2. Which is 105. Now what if they play each other twice? Just multiply that by 2. So technically I could go 15C2 times 2, which is 210. What if it's 3 times? 15C2 times 3, which is 315. I don't know why. It's super frustrating. The next one has, a circle has 8 dots on the outside edge. How many different triangles can be made using the circles as vertices? 1, 2, 3, 4, 5, 6, 7, 8 dots on the outside, right? How many dots make a triangle? 3. Does the order in which I pick those dots make a different triangle? No. Like if I go like this, or I go like this, or I go like this, or I go like that. I don't even know which ones I've done so far. Did it make a different triangle? So does the order matter? So how many dots do I have? 8, C, 3. 56. Next one says, in a room there are 20 people. Everyone must shake hands with everyone else once. How many different handshakes are possible? So I know I have 20 people, and I choose how many to shake hands? 2. Some people will say 20. That is the weirdest handshake ever. That's all 20 of you coming together and just doing like a break, you know, like in football. So it's 20C2, and that's shaking hands with each other once. What if I wanted twice? Times by 2. What if I wanted 5 times, which is super awkward and weird at that point?
Multiply by 5.
Multiply by 5. We're getting to cards. When we do cards, what is it? A permutation or a combination? Combination, because when it gets into your hands, what's the first thing you do? You organize it, move it around. So did the order in which you were dealt matter?
Plus it's 4.
Unless it's 4. So, using a standard deck of 52 cards where 5 card hands are dealt, so this one's a 5 card hand. Remember, it could be a 3 card hand, a 6 card hand. It could be whatever they want it to be, right? So we have to read properly. So it says 52 playing cards, 5 card hands are dealt. Determine how many hands contain 2 queens. So I go 4C2 and I'm done? Nope. I need 2 queens and what? Yeah, 3 not queens. Because how many cards do I need? 5. Do you think the answer to 4C2 will be on the test tomorrow?
Yes.
Absolutely it will. If you forget to supplement with the not queens, that answer will be there. All right. So we're going to go 4C2 times, how many are not queens?
48.
I'm going to start taking away phones. 48C what? 3. Why is it 48? Because you have to take all the queens off, not just the ones you use, not just the 2, right? You have to do 52 minus all 4 queens. Yeah. Yeah. At most 1 black. I have at most and I have at least. What's the problems with those? You're going to have what? Cases. Okay. So at most 1 black means at most $1 means 1 or less, right? So we could have 1 black or 0 black. Now what's the catch? How many card hands do I need? 5. So how many more do I need in this one?
4.
And 4 not black, which we could call red, technically, only because they're opposites here. 4, 0 black, and 5 not black. So how many black do I have to choose from? 26, half the deck. 26, choose 2. How many not red, how many not black, sorry? 26, C3. Plus 26, C0. Do I have to show this case where I'm choosing nothing? No. So I can leave this off if I wanted to, or I can keep it, and 26, C5. At least 3 spades means 3 spades or? At least 3 spades means 3 spades or what? 4 spades or 5 spades or more. And why do we stop at 5? Right, because I can only have 5 cards. So this one I need to supplement with and 2 not spades. And this would be and 1 not S. And that last one I don't have to supplement with anything. So how many spades are there? 13. 13 C3. Not spades? How many are not spades in a deck?
39.
39. Because you do 52 minus the 13 spades off, right? So it's 39 C2 plus 13 C4 times 39 C1 plus 13 C5. And if you're like, wow, I really hope she doesn't put in at least or at most case tomorrow, she's going to. She's me, I know it's on. So if you think like the ones that you think are a little harder aren't going to be there, they're going to be there. But we went over them like once every day the last 4 days. You're probably going to have it there. What's the problem with D? 1 queen, 3 kings. You're missing a card. That's only 4 cards, correct? So you need to and 1 what? Not queen, not king, yeah. So, how many queens are there? 4, C1, and 3 kings? 4, C3. How many of the cards in the 52 are not queens or kings? 44. How'd you figure that out? 52 minus 8. And yes, math. So it's 44 C1. Tomorrow, please make sure you're giving me answers, the actual solutions to those, type into your calculator. Now, 7 says, how many odd 6 digits are there without repetition? Wow, I've asked that question every single day since we learned it. Could we perhaps speculate that perchance maybe that would be on the test? Something like it, right? Maybe it's not 6 digits, maybe it's 5, maybe it's 4, maybe it's 20, I don't know. But you've seen it over and over and over. So, we need, I'm going to put down here because I don't have a lot of space, 6-digit numbers. So 1, 2, 3, 4, 5, 6. Odd means what? It has to end in an odd number. 1, 3, 5, 7, 9. Now sometimes it's less than that because sometimes I don't leave you all the digits, right? Sometimes I'm like, it's 1, 3, 9, 4, 2, you know what I mean? And you can only use what I gave you. This one didn't. So, because I can't repeat, what do I have to remember to do? Box and hold. Now, if you're someone who thinks tomorrow you're just going to look up all your notes because you don't know how to do anything, you will run out of time, just so you know. So, I would study if you're a little lost. What can't this one be?
0.
Or?
9.
Because I held it, right? So it can be 1 to 8, which is 8 options. Then I box the 8. What can this one be now?
0.
0 to 7, which is actually 8. Do you think the answer to 8, 7, 6, 5, 4, 5 is going to be there? Do you think you forgetting to remember to bring that 0 back, that answer will be on the test? Yes. It's often picked more than the correct one. You have to remember to bring that 0 back. So it's not 8, 7, it's 8, 8. Then we have 0 to 6, which is 7. 0 to 5, which is 6. And 0 to 4, which is 5. I should have this answer memorized because I think I've given this one the exact one a lot. 67,200. Now 8 says, Jeremy, Jesse, Jamie, Amy, Lori, and Crystal go to the movies. Now just so you know, Jeremy, Jesse, and Jamie are boys. Amy, Lori, and Crystal are girls. Because these are my brothers. I forget that they have my sister-in-law, and me. I omitted my other brother for some unknown reason. I don't know why. I mean, actually, no. I didn't omit him. I guess I didn't put my husband on there. My brothers are there. There's 3 brothers. I just didn't put my own husband. Nah, he's okay. All right. How many different ways can they be seated next to each other in the movie theater if there are no restrictions? If there are no restrictions and there are 6 people, what do we do? Yes. 6 factorial. 6, 5, 4, 3, 2, 1. 6 factorial, which is 720. Now the next one says the boys and girls must alternate. So you have to watch yourself on this one. So you can start with boys, or you can start with girls, which gives you 2 cases. So this would be 3, 2, 1, 3, 2, 1, and then this would be 3, 2, 1, 3, 2, 1. So it should be 72, not 36. Now we're flipping over. Okay, these pathways ones, remember I told you to treat it like D, 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 R, 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 and then this would be D, 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 R, 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 R. So this top one would be 1, 2, 3, 4, 5 factorial on the bottom, and then this would be 5 factorial on the bottom, and then what would go on the top? Now this one would be 5 factorial on the bottom, and then what? 3 factorial on the bottom, and then what on the top? And what do you do with your 2 answers? Multiply them, because I always say pretend there's like a dot in here to remind yourself that you're multiplying them. Now, could you just give this solution without the answer? Just write it like this for me tomorrow? No, get the answer. We're in time constraints. I have till 1:31, so I got to get past them. So please type that in and give me an actual answer. Yeah. 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 Now this one would be D, 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 R, 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 R. These are for down, R's are for right, not just random letters. So this one would have 3 factorial on the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factorial for the R's. What would go on the top?
14.
14 factorial. Then multiply D, 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 R, R. So this one would have 3 factorial, 2 factorial. On the top would be 5 factorial, yeah. And this one would have D, D, R, 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 R. So it would have 2 factorial, 6 factorial on top. And we multiply it all out and give me an answer, correct? Okay. 10 says how many 3-digit numbers less than 700 can be used creating that? Less than 700 means the first digit needs to be less than a 7, correct? Repetition is allowed. So my first option would only be 1, 3, 4, 5, which is 4 options. Do I need to box and hold when repetition is allowed?
No.
Do I need to box and hold? No. How many letters do I have for the next 2? 7. So it should be 196. Repetition is not allowed, so now we box and hold. Still? 1, 3, 4, 5, so there'd be 4. But now I'm holding 1. So then I'd have 6, and then 5, which is 30 times 4, which is 120. Eleven says, give me every different way you can represent the situation. There are 32 students in Mrs. Lepp's Math 30-2 class. She's randomly choosing 6 of them to go on a trip to 7-Eleven. How many different ways can Mrs. Lepp do this? If I'm picked first, second, third, fourth, fifth, or sixth, does it make me any difference? No, I just get to go to 7-Eleven, correct? So it is a perm where order matters, or a combination where order does not matter? Combination, because if you're picked first or sixth, you get to go to 7-Eleven. So we can go 32, C, 6. What else can we do? 32, C what? Remember, you can take the difference of the two, only with the C. So you can go 32 minus 6, which is 26. These will result in the same answer. In the notes, we did 10C6 and 10C4. We did this in your notes. And we found out that if it's a common difference, it's the same, and I showed you with the formula. The other way you could do it as well is you could go 32 and 6 and 32 and 26. Because remember, C has that weird brackets like that. You can do that as well. NCR, NPR. NCR is a combination order, doesn't matter. NPR is a permutation order matters, right? Difference would be, if I had 32 kids in the class and 6 of you got to go to 7-Eleven, that's a C. If I had 32 kids in the class, 6 of you got to go to 7-Eleven, and you all had 6 different jobs while walking to 7-Eleven, then it would be a permutation, because order would matter. Now, 100 people enter their name into a draw to win 3 prizes. How many ways can 3 prizes be drawn if they're the same? Does order matter if they're the same? Does order matter if they're the same prizes?
No.
No. So this one would be 100 C3. What if they're different prizes? 100 P3, because then the order would matter. If you were first, second, or third, you would get a different prize, right? Now here, a powerhouse committee is being formed from the school division made up of 25 principals, 250 teachers, 8,000 students. They are wanting to form a subcommittee to discuss issues throughout the school division. They are wanting a 12-person subcommittee. How many subcommittees can be made? So when we add them all up, 8,000, 250, and 25, we get 8,275, right? Does a subcommittee have jobs? Are you different if you pick first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, or 12th? No, so what am I going to use? C or P? C, because order doesn't matter. And I'm choosing 12. The next one says there must be 2 principals, 3 teachers, 7 students. Is that total 12? 2, 3, and 7? That totals 12, right? So there's enough. How do I guarantee getting principals? Choose them from the principals. So I go 25 C2 teachers, 250 C3 students, 8,000 C7. And they'll often leave it like that because you just get a giant number. Your calculator is not happy with it. So you just leave it. Now this one says there must be 7 students. Is that 12 people? You always have to remember when you have subcommittees of 12, you have to supplement, right? So I have 7 students and 5 not students. I just love how this makes an extra line every time I make 5s. Just bringing me great joy. It is not. Stupid board. So 7 students. I do 8,000 C7, and then I need not students, so everyone else. So that's 275 C5. Keep making those lines board. Now this one says there must be at most 2 principals. So that's 2 principals, 1 principal, or no principals. Correct? So we have 2 principals and 10 other. Or 1 principal and 11 other. Or 0 principals and 12 other. So, principals, there are 25, C2. Others, there are 8,250, C10, plus 25, C1. We get a new case, start over again. 8,250, C11, plus 25, C0, times 8,250, C12. So close. Jim decides to line up some cars at his dealership. He has 12 cars in total, 6 black, 3 gray, 3 blue. Determine how many ways he can be arranged if the cars are not identical, if the cars are identical. If the cars are identical, what happens? Nope. If the cars are identical, it's like having this. B, 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 G, 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 and blue, blue, blue. Can I tell them apart? No. It's like having those letters, right? So you have 12 factorial on the top, but on the bottom, when they're identical, you have to divide by 6 factorial for the 6 black that look the exact same. 3 factorial for the 3 gray. Oh my gosh, that was the same. And 3 factorial for the 3 blue. Whereas when they're not identical, it's 12 factorial, right? So you have to remember when you are given identical objects, you have to divide by factorial. So if I gave you flags and they were identical blue flags and green flags and pink flags, and you start with a blue flag and you end in a pink flag, that's great. If they're identical, you still have to divide by the factorials of each of them because they look the exact same. Then here it says a menu consists of 4 appetizers, 5 main course, and 6 desserts. I want 1 appetizer, 1 main course, 1 dessert. So when I take principals from principals, students from students, teachers from teachers, dessert from dessert, main course from main course, I use C's, correct? You use C's whenever you choose, like defense from defense, forwards from forwards. So this one I'm going to have 4C1 times 5C1 times 6C1. And this one I'm going to have 4C2 times 5C1. Dessert from dessert, 6C2. That's my differences. You're here for a grad credit check, so you're not leaving. Just an FYI.